After completing the robot car assembly, we are going to connect the Nano board with our computer through a USB cable. On our computer, we open our Arduino software. I'm going to go to File, and I'm going to open a test code called HC05 bridge, which has the function of placing the Nano board as a bridge between our computer and the HC05 Bluetooth module, and which will allow us to verify what information is sent by our control application called Accelerometer Sensor Bluetooth, which we will later install on our Android phone. I leave you this Arduino bridge code in the description of this video in case you require it. We go to Tools, Board, and select the board we are using, in my case the Nano board compatible with Arduino. We go to Tools, Port, and select the port to which our board is connected, in my case COM3. We click on Upload, and we upload this program to the board. We open the serial monitor tool of our Arduino software. Next, on our Android phone, we enter the Play Store. In the search bar we enter my user developer name, and click on the Accelerometer Sensor Bluetooth application. Click on Install until the installation is complete. If we have not done it previously, before opening the application, on our mobile phone we access the Bluetooth device configuration, select Synchronize New Device, and wait for the device search. We select our HC05 Bluetooth module. We enter the key to pair it to our mobile phone, which is usually 1234, and we accept. After pairing them, we select to open the application. Having the Arduino board connected to our computer via the USB cable. In the application we click on Connect and select our HC05 Bluetooth module. Once the module is connected to our phone, and paying attention to what is illustrated on the serial monitor on our computer, we can see the following. Pressing the forward arrow, the app sends the letter F to the Arduino, and releasing the arrow sends the letter S. Pressing the right arrow, the app sends the letter R to the Arduino, and releasing the arrow sends the letter S. Pressing the back arrow, sends the letter B to the Arduino, and releasing the arrow sends the letter S. Pressing the left arrow, sends the letter L to the Arduino, and releasing the arrow sends the letter S. So, on this occasion, we will learn how to program the Arduino board to interpret these characters and apply them to the movement of the robot car. Now let's activate the XYZ control function, and from this moment, as we can see in the serial monitor of the Arduino software, the application sends to the Arduino via Bluetooth the components of the mobile phone's accelerometer sensor in meters per second squared, through the variables X, Y, and Z. This allows the tilt variations of our mobile phone on the axis. Negative Y, positive Y, positive X, negative X, and the Z-axis. They are captured by our Arduino board in the form of text, so this time we will learn how to program the Arduino to read these text strings, and specifically extract the information we need, in this case and depending on this information, assign the inclination of our phone to the movement of our robot car. To do this, we are going to start from the test program that I already have, HC05 Bridge, in which we include the software serial library. With the support of this we create a serial logic interface that will allow us to communicate the Nano board with the HC05 Bluetooth module, on digital pins 3 and 2, as receiver and transmitter respectively, and which I named BT according to my preference. Inside the void setup method, we initialize the only physical serial interface of the Nano board, known as serial, with a transfer rate of 9600 bauds, and we initialize the BT logical interface with a transfer rate of 9600 bauds. I'm going to go to File, Save As, and I'm going to save this new program with the name, Robot Car Control. Inside the void loop method, we are going to create a serial data reception routine, letter by letter, in the BT serial interface, which is where the data from the Bluetooth module will be received. To do this, we are going to create an if-type control structure, where we will verify that there is availability of data received on the BT interface. If there is data available, we read the data that has been received, and we store it in a char-type variable that I will call C. From the test we did previously, we know that, in manual control mode, the application sends 5 characters to the Arduino board, the characters F, B, R, L, and S. For this reason, we created 5 if-type control structures, in which we will evaluate which of these characters has reached the BT interface on the Arduino board. When the variable C is equal to F. When it is equal to B. When it is equal to R. When it is equal to L. And when it is equal to S. Inside the void setup method, let's place 4 instructions to initialize pins 5 to 8 of the Nano board as digital outputs. These will be the 4 pins that will control the 4 inputs of the L298N module, and that will finally give movement to the gear motors and the wheels in one direction or another. The L298N motor driver module. It has 4 inputs that go from IN1 to IN4, and it has 4 outputs corresponding to each of these inputs, which allow it to control 2 motors. The inputs IN1 and 2 can control the outputs OUT1 and 2 correspondingly, that is, the first gear motor. Setting input 1 high, and input 2 low, will move the first gear motor in one direction. Setting input 1 low and input 2 high will move the first gear motor in the opposite direction. Setting both inputs, 1 and 2 low, will not move the motor in any direction, it will remain still. The inputs IN3 and 4 can control the outputs OUT3 and 4 correspondingly, that is, the second gear motor. Setting input 3 high, and input 4 low, will move the second gear motor in one direction. Setting input 3 low and input 4 high will move the second gear motor in the opposite direction. Setting both inputs, 3 and 4 low, will not move the motor in any direction, it will remain still. For this reason, in our program after the void loop method, we create 5 methods. The forward method. The backwards method. The right method. The left method. Within the forward method, we write the 4 outputs of the Arduino board with the corresponding values to move the 2 geared motors in the same direction forward. Within the backwards method, we write the 4 outputs of the Arduino board with the corresponding values to move the 2 geared motors in the same direction backwards. Inside the right method, we write the 4 outputs of the Arduino board with the corresponding values to move only 1 gear motor, the one corresponding to the left wheel, and leave the other gear motor without movement, the one for the right wheel. Inside the left method, we write the 4 outputs of the Arduino board with the corresponding values to move a single gear motor, the one corresponding to the right wheel, and leave the other gear motor without movement, the one for the left wheel. Then, in the if structure that identifies the character F, we call the forward method. In the if structure that identifies character B, we call the backwards method. In the if structure that identifies the character R, we call the right method. In the if structure that identifies the character L, we call the left method. In the if structure that identifies the character S, we call the stop method, which we have not created yet. Then we create below this method, the stop method, where we write the 4 outputs with a low value to leave the 2 gear motors still, that is, to stop the robot car. In case the interface receives characters other than these 5 that we have already described, let's place an else structure, and inside this we will process the character corresponding to the cell phone accelerometer data, that is, the X, Y, Z data. Before starting with this configuration, we go to the initial space of the editor, and create a string type variable or text string, with the name content and initialize it empty. The content variable will store all the characters that the Arduino Nano board receives from the cell phone's accelerometer sensor. Inside the else structure, each character we receive, other than the 5 characters discussed above, will be added to the text string with the name content. We create an if structure, in which we evaluate whether the character that arrived is the line break character, that is, the last character sent in each text string from the phone. The line break character cannot be observed in our text, but it is implicit in the text string received, since we can see that each data string sent by the cell phone is written on a different line, so there is a break between them. The line break character is represented in any programming language, such as \n. To extract the numerical values of X and Y from the text string received on the Nano board, we are going to use 2 very important methods of the string class. When defining a variable as string, we are defining an object of the versatile string class, which has a series of available methods, and of which we will use 2 in our development, the index of method, and the substring method. Then we create three numeric variables of integer type to store the position in which the characters x, y, and z are located. We do this by applying the index of method to the content string. What we did here is the following. The variable content has a text string stored, where the first character received from that text occupies position 0, and the last character occupies a position equivalent to the length of the entire string, I will call it L, and all the characters that are in the frame occupy a position between 0 and L. By applying the index of method on this string, and supplying a text as an argument, it will return the position where it finds said argument, that is, a positive number between 0 and L, the total length of the string. If it does not find the requested argument in the entire text string, it returns a negative value, that is, -1. By applying the first instruction, we obtain the position of the text, x:, within the entire text string. By applying the second instruction, we obtain the position of the text, y:. By applying the third instruction, we obtain the position of the text, z:. To ensure that we obtain positive numerical values in the three POS position variables, we can place an if control structure, in which we evaluate in a conjunction that all positions POS1, POS2, and POS3 are positive numbers. If this is true, and knowing the value of these positions, we extract from the text string the text representing the number of the variable, x, and the text of the variable, y, and store them in two variables of the string type, the variable xstg, and ystg respectively. What we did here is the following. The substring method extracts a portion of the total text string, and is supplied with two arguments, the first argument the start position, and the second argument the end position for extraction. Reason why, to extract the numerical value of x, we indicate to the substring method the initial position equivalent to POS1 plus 2, that is, this point, and as the final position we indicate the value of POS2, that is, this point, to extract this portion of the string. And to extract the value of y, we indicate to the substring method the initial position equivalent to POS2 plus 3, and as the final position we indicate the value of POS3, to extract this portion of the string. Once we have the text strings xstg and ystg, we convert them to floating numerical values and store them in the variables x and y. Having already these variables, we can now make decisions to move the robot car according to them. As we know, the gravity value of the Earth is approximately 9.8 meters per second squared. For this reason, the values for x and for y, provided by the mobile phone's accelerometer when tilted, will vary in a range between approximately -10 and 10 meters per square second. So, I will code 5 if condition structures, to evaluate the 5 types of states of the robot car. If x is less than -2, that is, when we tilt the phone forward, we call the method to move the cart forward. If x is greater than 2, that is, when we tilt the phone back, we call the method to move the cart backwards. If y is less than -2, that is, when we tilt the phone to the left, we call the method to turn the cart to the left. If y is greater than 2, that is, when we tilt the phone to the right, we call the method to turn the cart to the right. Finally, when both x and y are in a range between -2 and 2, that is, with the phone without tilt or with a minimum tilt, the vehicle must be stopped by what we call the stop method. And that's it, we upload the program to the Arduino board. I leave this code in the video description. Finally, we disconnect the USB cable from the Nano board. And we placed 2 rechargeable lithium batteries of the 18650 types, with a voltage of 3.7 volts. And voila, we have a fully functional robot car. Let's see the result.